In section 2.1, we learned how to solve equations by adding or subtracting the same quantity from both sides. In the first part of section 2.2, we learned how to solve equations by multiplying both sides by the same number. In this part, we're going to combine those two skills. If I have a problem like 6x plus 5 equals negative 13, and I'm asked to solve this for x, notice that I have an equal sign here, which is acting like a balance. On one side of my balance, I have 6x plus 5. On the other side of my balance, I have negative 13. If I want to solve for x, then I need to get it completely by itself. If I can't do that by dividing the left-hand side by 6, in other words, by using the multiplication property of equality, then let's see if we can use the addition property of equality. What if I subtract the same amount from both sides? The 5 here is kind of hanging off by itself. If I took 5, if I reach over and pick up 5 and take them away, and I do the same thing on the other side, then I end up with this. 6x plus 5 minus 5 is 6x plus 0, or just 6x. Here's my equal sign. Negative 13 minus 5 is negative 18. What if I had given you this question to start with? Well, now it's easy. Now it's just a multiplication problem. So I can divide both sides of my equation by 6. And I'm safe in doing that this time because there's nothing hanging off the end here that's going to get in my way. 6 cancels with 6, leaving me with x. Negative 18 divided by positive 6 is negative 3. So my answer is negative 3. Let's test it and make sure it worked. The original equation was 6x plus 5 equals negative 13. So I'm going to rewrite that equation with blank or empty parentheses instead of my x. Then I'm going to take the value I found for x and try it in its place. Order of operations gives me 6 times negative 3 is negative 18. Negative 18 plus 5. Is that equal to negative 13? It is. So my answer works. My answer is not negative 13. My answer is the number I tested, the number I found for x. This number is the correct answer. The thing to recognize in a problem like this is that instead of a single step being enough to solve the equation, adding the same thing to both sides or multiplying both sides by the same thing, we had to take 2 steps. We used the same properties, but we had to use them both in solving one equation. Here's another one. 3x minus 4 equals negative 2x plus 6. Solve this equation for x. The thing about solving for x is that my goal is always to get it completely by itself. And if you'll remember from the last example in part A of this section, sometimes that means combining like terms. Sometimes it means finding a way to get all of your constants together and all of your variables together. Here, I have x's on this side and x's on this side. Not only that, but I have constants on this side and constants on this side. So let's start by moving our variable terms around so that they're all on the same side. There are multiple correct ways to do this, but I'm going to start by saying I don't want this here. I want all my x's on this side. I want my equation to end up x equals, to do that, my x's are going to have to be over here. So that means this negative 2x is on the wrong side, so to speak. If this is on the wrong side, how do I get it on the right side? More importantly, how do I get it off this side? Well, what I've got here is negative 2x's. To counteract that, I could add 2x's, because negative 2x plus 2x is 0. When I add these two lines together, this is going to add up to 0. The thing is, if I do that here, on the right-hand side of my equal sign, then of course I must also do it on the left-hand side. Let's see what happens when we collapse these two. 3x plus 2x is 5x, but negative 2x plus 2x is 0x. Of course, I don't need to write that term. 0x is just 0. What do I have left? Well, I still have minus 4, and I still have plus 6, or just 6. So I have a new equation now. 5x minus 4 equals 6. I've managed to get the equation into a form where all the x's appear not only on one side, but all in one term. They're all in one big pile. This question now looks like the last one that we did. I have x's on this side, but I also have constants on this side. So the next thing I'm going to need to do is add 4 to both sides. And the reason for that is I want to go in and divide by 5, but I can't do that yet. I have to get rid of the 4 first. So now I have 5x plus 0, or just 5x, equals 6 plus 4, which is 10. Lastly, since this is a multiplication, I can multiply both sides by 1 over 5. 1/5 of 5 is 1, and 1/5 of 10 is 2. I don't need the 1, and there's my answer. Let's check it. 3x minus 4 equals negative 2x plus 6. When I rewrite this with blank spaces, I get this. Then I can go back and fill in the spaces, the empty spaces, with the number that I'm testing. The rest is arithmetic. On the left-hand side, I have multiplication first, 3 times 2. And on the right-hand side, I have negative 2 times 2. Is this a true statement? Does 6 minus 4 equal negative 4 plus 6? It sure does. That means the answer I found, the number I'm checking, 2, is the correct answer. I want to take a look again at this step right here. 5x minus 4 equals 6. I see this error so often, it really is worth talking about. The temptation for a lot of people is to divide by 5 because it feels like that's what's in the way of getting the x by itself. Now at this point, this is a legal move. Dividing both sides of an equation by the same number is fine. It's what you do next that's really important. I'm going to do this in red because this is actually technically incorrect. Here's where the mistake often comes in. 5 divided by 5 is 1, but this canceling is incomplete. Here's why. If I have 3 plus 9 over 6. One way to do this problem would be to say 3 plus 9 is 12 over 6. 12 divided by 6 is 2. And I think we'd all agree that that was fine. We did this top addition first. It's kind of like saying it's in parentheses. We divided the result by 6. This is actually the correct answer here. If I use this technique of canceling first, then what I'm saying is 3 goes into 3 once. 3 goes into 6 twice. Does this give us the same answer? 1 plus 9 is 10 over 2. 10 over 2 is 5. We don't get the same answer. So one of these is incorrect. The problem lies with this plus sign right here. The fact that I'm dividing this sum by 6 means I really need to divide everything by 6, not just a part of it. When I add these two together and I get 12, if I reduce this by dividing both of these by 6, I get 2 over 1. But that's because I divided 12 by 6, not just the 3, but the 3 plus 9, the 3 and the 9. So I can divide both sides of this equation by 5, but I can't cancel like this unless I also cancel with the 4, and this clearly doesn't work. So be careful when you're doing a problem that looks like this. The best way to approach a problem like this is to get in the habit of leaving this term alone at first. Get rid of the 4. Get rid of the constant first. Then go back and divide both sides. Okay, because I know how much you like them, I'm going to do one with fractions. 2/3 x plus 1/2 equals negative 3/4. When I see a problem like this nowadays, I think a number times x plus a number equals a number. I don't really care what the numbers are. I know what matters is the process. I can write down the steps that I'm going to take and probably even get some partial credit for it, even if I can't do the arithmetic. Then by the time I get to the arithmetic, I usually find that it's not as bad as I thought it was going to be. All right, let's get rid of this mess and take a look at this problem properly. Here's a number times x plus another number equals a third number. In the last example, I showed you that the best approach when you have an equation in this form is to move the constant, get rid of the constant first, then go back and deal with the number in front of the x. To get rid of this number, it's added to the left-hand side right now, I want to subtract it. If I subtract it from the left, I must also subtract it from the right. That gives me 2/3 x, because I haven't done anything to that yet, plus 1/2 minus 1/2, which is plus 0, and I don't need to write that, equals whatever this is. I've come a fair way in this problem without actually having to do any really hard math. The plus 1/2 minus 1/2, well, that's just 0. I didn't do anything with this term at all. I just dropped it down to the next line. The first time I have to do any arithmetic with fractions is in this step here. You can do this however you like. I'll do it on paper here, but try it on your calculator as well. Negative 3/4 minus 1/2. Addition or subtraction of fractions. I have negative 3 plus negative 2 fourths. This arithmetic gives me this number, so I can replace this with negative 5 fourths. On your calculator, you'll need to use this little symbol first for the negative. Then type 3 divided by 4 minus, that's the regular minus key, it's right under the plus key, minus 1 divided by 2. Your screen should look like this. That's a little exaggerated because I'm trying to write out by hand what the calculator screen is displaying. This leading negative here is actually smaller than the minus sign. When you type divided by, you get this little slash. It's like writing a fraction because that's exactly what this is. In reverse, you could say that negative 3 over 4 means negative 3 divided by 4. These are equivalent. So if I want to figure out what a fraction is on my calculator, I need to type 3 over 4. But the way you do that is 3 divided by 4. When you hit enter, you get negative 1.25 on your screen. If you then type the math key and then the enter key, and then the enter key one more time, your calculator will display the fraction negative 5 over 4. So although I did this on paper the first time around, I've shown you also that you can type it into your calculator and get the same result. Now that I've got this equation down to a more manageable size, let's finish it up. I have a number times x equals a number. We can either multiply both sides of the equation by the same fraction. We want this to be 1 when we do that multiplication. So let's multiply by 3 over 2. This is going to become 6 over 6, which is 1. If I do it on one side, I have to do it on the other side. This multiplication gives me negative times a positive is a negative. This is 15 over 8. I don't need the 1. My answer is x equals negative 15 over 8. What if I don't like multiplying by fractions? What if I'm really stuck on trying to divide both sides? Well, I can do that too. I can think divide both sides of the equation by the number in front of x. Divide both sides by the fraction 2/3. I still get here a number divided by itself. That number divided by itself is 1. And this equals negative 5 fourths divided by 2/3. Let's move the rest of the problem up here because I've run out of room. 1x is just x. And negative 5 fourths divided by 2/3 is the same as negative fourths times 2/3 flipped over, 3/2. To do this arithmetic, I just need to multiply straight across, top and bottom. Negative times positive is a negative. 5 times 3 over 4 times 2. If you'll remember, that's exactly the answer we got the last time. Which approach you use is entirely up to you. The addition and multiplication properties of equality are very important in algebra. They're used in combination to solve a lot of different kinds of problems. We'll also use the distributive property and the associative and commutative properties of addition and multiplication. These are your basic building blocks of algebra. Using these tools in combination can help us solve really quite complex problems.